The diagram below shows the graph of the function f of x equals minus x cubed plus ax squared plus bx plus c, and a and b are turning points, with b having coordinates 6 and 0. Okay, and now we continue to say the first question 5.2.1 says determine the values of a, b, and c in f of x, which equals minus x cubed plus ax squared plus bx plus c. Okay, so we continue and we look at 5.2.1. 5.2.1. So now 5.2.1 looks at the function f of x. And this function is minus x cubed plus ax squared plus bx plus c. At the points 0 and 0, you have that f of 0 is equal to minus 0 cubed plus a into 0 squared plus b into 0 plus c equals 0. And what we're getting out of these is that c is equal to 0 because the rest of all these disappear completely. So what you have, for instance, is that this will become 0, that becomes 0, and that becomes 0. We're therefore left with c equals 0. So we have therefore found the numerical value of c. Right, moving forward, we continue to explore this, but there's another point. We've seen that at the point B, and B has coordinates 6 and 0. 6 and 0. Right, the point B would have therefore f of 6, which is minus 6 cubed plus a into 6 squared plus b times 6. C is already 0, and this becomes equal to 0 at the point B because y is not there. And what we're then getting, upon division by 6, we're able to get that minus 36 plus 6a plus b is equal to 0. So we have 6a plus b, which equals 36. Okay, this is one equation. The point B is a turning point. So at the point B, whose coordinates are 6 and 0, we're able to realize that the point B is a turning point. And the function f of x is minus x cubed plus ax squared plus bx plus c. And therefore now you have f primed at the turning point, and this f primed is then equal to the derivative minus 3x squared plus twice ax plus b, because c is a constant. Okay, and obviously at the point B you have that the derivative. So in other words, you have that f primed of 6 is equal to minus 3 into 6 squared plus 2a6 plus b, and this is equal to 0. At the turning point, the first derivative is 0 of the function. Okay, and therefore if we multiply all these, it becomes minus 3 times 36, because 6 squared is 36, giving us minus 108 plus 12a plus b, and this is equal to 0. We continue with the simplification, getting 12a plus b is 108. Now we proceed to consider the two equations we've thus obtained. So we consider (6a plus b), which is 36, and that gives us equation 1. And therefore you have 12a plus b, and that's 108. That's equation 2. And these become equations to be solved simultaneously. And we shall say equation 2 minus equation 1, we have 12a minus 6a, which gives us what? It gives us 6a. 108 minus 36 gives us 72. And we divide through by 6, obtaining 12. And you have therefore, we have therefore using, for example, using one of the equations, equation 1, which is 6a plus b equals 36, you'll have therefore that you have 6 into 12 plus b, which equals 36. Upon further simplification, we're able to achieve that b is actually equal to minus 36 units, or just minus 36. All right, and we've got that. So with that in mind, thus we're able to infer that a is equal to 12, b is minus 36, and c is 0. Okay. We continue to look at 5.2. 5.2.2, and that is very, very similar to, in fact, it's in context very, very easy. Let's just go back to what we actually had just now. 5.2.2 says, explain what happens with the curve at the point of inflection. At the point of inflection, so we have the point of inflection clearly here, and the point of inflection is this one. And you clearly can see that the concavity of the curve changes. Its concavity changes there, so that's what we say. We say the concavity changes at the inflection, at the point of inflection. So just have to explain. So concavity changes. Concavity changes. Now, this next thing we want to look at is to analyze 5.2.3, and that is we have f of x. 5.2.3, for instance, asks us to do what? Let's just check quickly, so that we can be on the same page. Determine the equation of the tangent at the point t. Okay, the equation of the tangent at the point t, in fact, they said, or it should be, is given as y equals 9x minus 54. We need to determine the coordinates of t at that point. So we continue quickly to do that one. And so we're going to do it as follows. We remember the function f of x, which equals x cubed plus ax squared plus bx plus c, which means you have f of x. So you plug in everything there. You plug in the values of a, b, and c that we've got. So we've got that the value of a is 12x squared, the value of b is minus 36, this is an x. The value of c is identically 0. With this in mind, we're able to find the first derivative of the function there. And obviously we note that it's minus there, it's minus x squared, so that minus x cubed, excuse me, so that we have minus 3 minus 3x squared plus 24x minus 36. And now what this becomes is as follows. Right, so the equation of the tangent at t the equation of the tangent is y equals 9x minus 54. Now we're going to find the derivative there of in fact we've already found the first derivative, so we need to note that at that point what we have is that okay, what we have is that now the first derivative f prime of x, which is minus 3x squared plus 24x minus 36, is equal to 9. And therefore what this becomes is minus 3x squared plus 24x minus 45 is equal to 0. Alright, we perform further division by minus 3, getting x squared, okay, minus 8x plus 15 is identically 0. And now at the end of the day, you have x and x, minus 5 and minus 3, getting x equals 5 or x equals 3. Okay, so those are the values of x, okay, and using the equation of the tangent at t, which is y equals 9x minus 54, we're able to find that at x equals 5, y becomes 9 times 5 minus 54, and therefore y is 45 minus 54, and that is minus 9. So that means we have the point x is 5 and y is minus 9. At x equals 3, y equals 9 into 3 minus 54. and this gives us 27 minus 54, which is minus 27. X is 3 and y is minus 27. Okay, with this then we're able to find in fact therefore infer that, so we got 2 points. So 2 points, and these 2 points are 3 and minus 27 together with 5 and minus 9. Together with 5 and minus 9. Okay, 5 and minus 9. Now, the question we ask ourselves is, which one is t? You realize, therefore, that we infer that t is has x equal to 3 and y equals minus 27. Why am I saying that? I'm effectively saying that because if you look at the graph has a point of inflection 4 and minus 6. X is 4 at the point of inflection, and therefore before x equals 4, we can realize that therefore x must be exactly 3 there, and therefore we have that the coordinates of t must be 3 and minus 27. Let's see what else we need to do here. Determine the coordinates of t. We have found the coordinates of t, and obviously we are done with this question, and therefore thanks everybody, a goodbye to you. Very, very goodbye to you.